Good morning, Dad.
Good morning.
So I need your help with something. I was in the hot tub the other day and I was all by myself, so I was really bored. So I decided to get some toys, and when I put them in the hot tub, some of them floated and some of them sank. And it got me wondering, what makes some things sink and what makes some things float? Do you have any idea?
Probably air inside the ones that float.
Air inside the ones that float? That's a good observation. So I have some objects that we are going to predict whether they float or sink. So I'm going to give you this worksheet, and remember to put your name at the top. So now I'm going to give you these objects, and I want you to touch them and observe them and make a prediction on your sheet as to whether you think they're going to sink or float. And once you've made your prediction, I want you to make an X under which column you think it will happen. Okay, so now that you've made your predictions, we're going to test out the objects. So I'm going to drop the aluminum foil ball in the water. And over here on the results column, if it floats, I want you to write an F. And if it sinks, I want you to write an S. And we're going to do that for all of the objects, okay?
Okay.
So let's see if it floats or sinks. It floats. Was your prediction correct?
Yes, teacher.
Good. And the next object is a metal spoon. What'd you predict?
Sink.
You said it would sink. That's correct. Let's do the pen. What was your prediction?
Float.
Correct. Why do you think the pen floats?
Because there's a hollow space in the cylinder, that air.
So you've mentioned air twice now, so you think that...
It's not just air, I believe it's also density of the object versus density of the water.
I like your choice of vocabulary. Let's keep going. Key. You said that it would
Sink.
sink. Correct. And then the plastic spoon.
Mm-hmm.
You predicted that it would
Float.
float. And you're right. Why do you think that a metal spoon sinks but a plastic spoon floats?
I think the mass, the weight, the density.
And then we have a plastic straw. And it floats. Was your prediction correct?
Yes.
And then we have an orange. And it floats. What was your
I
prediction?
was wrong on that one.
You said it
I said it
sank.
would sink.
It floats. Why did you think that it would sink?
The weight, which makes me think that the skin is trapping some air between the skin and the fruit.
I like your critical thinking. And let's point out that it's not all about weight, because what weighs more, this orange or this key?
Exactly. Yep.
The orange does, and the key still sank. Now let's do the orange without the peel. And it sinks.
Sank.
And we'll explore why later on. Okay, next we have the rock. You predicted that it would sink.
Sink.
You're correct. And lastly, we have the dog bone. Let's see. And that sinks. Your prediction was right again. Okay, so now we're going to look a little bit further and explore some more objects that float or sink. So what do you think will happen when I place this aluminum boat in the water?
Float.
Why do you think that?
Because it's a light object. The weight is spread out over a large area. It's less dense.
You're correct. Okay, so for the next object, we have a tomato. What do you think's gonna happen with the tomato?
Think
Why?
it's dense, it's small. So it's probably as heavier than this object, but it's much smaller area.
So are you saying you think it's about weight or?
I think it's density versus the water density.
Okay, let's see. Sinks. All right, next object, we are going to find the paper clip. What do you think happens to the paper clip?
Sink.
Why?
I think again, density.
Okay. You're correct. Let's try latex glove. What do you think's gonna happen with the glove?
Flow.
Okay. Let's try the golf ball. What do you think's gonna happen with
Sink.
the golf ball? Why do you think it'll sink?
Because I've hit a lot of golf balls into ponds.
So through experience, you've seen golf balls hit
Yeah.
sink. You're correct. Okay, now we're going to try the rubber ball. It's quite large, so I'm going to remove some of the objects. What do you think's gonna happen to the ball?
Float.
Why do you think that?
There's air.
You're correct. Okay, now we're going to try a water bottle.
Float.
Why do you think that?
Same as the ball.
So you're noticing patterns? Okay, we're gonna try the scissors. What do you think?
They'll sink.
You think the scissors will sink? You're right. Why do you think that they sank?
Density, weight.
Okay. What do you think's gonna happen to the apple?
It'll sink.
Do you think it'll sink?
I should have known that.
The apple floats.
It's molding for
Why do you
apples.
think? Aside from personal experience, you should have known that.
I should have
What
known
else?
from experience. The other thing is the core. There's hollow spaces inside the core, so the apple's actually more similar to the ball than to the pen.
So you think what's inside of an object is important?
Yeah, it's just like a big heavy boat, metal boat.
I like that you made a connection to a boat. Okay, so now we're gonna do a mug. What do you think the mug will do?
It'll float
You think it'll float?
for a while.
So it was floating at first. Let's keep a close eye on it and see if anything changes.
It must be sitting on the bottom right now.
Let's look at the side right here. What's that coming in? Can you see? What's that coming in the mug? Right here.
Coffee?
No,
Water.
it's not coffee. Water. Water's going into the mug. So what do you, if water fills the mug, what do you think is gonna happen?
It will sink like a boat would sink if there was a hole in a boat.
I really like that connection. Good job. Okay, so now that we've explored 20 items that float and sink, that makes me wonder what the reason for this is. I heard you mention some really good vocabulary and ideas. So let's watch this quick video and see.
Hello, friends. Seems my voice has changed a bit due to the cold. Anyway, today we will learn about floating and sinking. Have you ever wondered why some things float and some things sink? Let's learn about floating and sinking today. What causes some things to float and some to sink? Well, it's all about something we call density. Don't worry, let me explain this. Everything around us is made up of small molecules. In some objects, tiny little objects called molecules are tightly packed together. And in others, they are loosely packed together. This is actually what density means. The objects that are tightly packed together have a higher density, and the more loosely packed objects aren't that dense. Whatever objects sink are more dense. See the stone? These marbles? And yes, these coins. They all sink in water because the molecules are jam-packed in these. Similarly, whatever objects float are less dense, like this rubber ball, this plastic bottle, and this lovely balloon. They all float in water because the molecules are loosely packed in these. Some boats and ships are large and would seem very dense, but
So we'll see about boats and how they stay afloat later on. Okay, so now after watching that video, I'm going to give you this worksheet. Don't forget to put your name at the top. And as we go through the PowerPoint, we're going to fill in some things about density. Don't forget to write your name.
Thank you, teacher.
You're welcome. Okay, so what is density? Density is measured based on how compacted do you remember?
Molecules.
The molecules are inside of the object. Good job. An object with tightly packed molecules is considered
More dense.
more dense. Good job. And an object with loosely packed molecules is considered
Less dense.
less dense. Good job. So here's a visual to help you visualize what's more dense and less dense. For more dense, these are the molecules, the green things. They're really tightly packed together, really close. And in this one that's less dense, the molecules are spaced out. So the density of an object can change. Do you remember how the mug was floating?
Mm-hmm.
It was floating because it had air inside of it. And then we saw the water start to seep in and replace that air, so it began to sink. So if air is replaced with
Water.
the object will become
More dense.
more dense than water and sink. Good job. But wouldn't two of the same object have the same density? Do you remember when we put the orange with the peel?
That's the one I missed.
Yep, you missed that one. It was tricky, huh? The orange with the peel floated because the air inside the orange was protected and unable to be replaced by water. So your prediction was kind of on the right track. And the orange without the peel sunk because water was able to replace the air and make the orange more dense and make it
What's
sink.
interesting is the peel must not allow the air to escape.
Mm-hmm.
So that's quite interesting about the orange peel.
Yes, it is. An important takeaway is not all heavy things sink. Ships are extremely heavy, but they're less dense because they have so many compartments inside that are filled with air. So looking back at what happened with the mug, if a ship's air got replaced with water, what do you think would happen? I heard you make a prediction earlier about it.
It would sink.
It would sink. You made a connection to a ship. So let's find out through learning about the Titanic. So we have a short video to watch.
The sinking of the Titanic, 1912. The The luxury British disaster. In the morning of April 10th, 1912, passengers began boarding the Titanic in Southampton, England, with large crowds gathering to watch the ship depart. At noon, the Titanic set sail under command of Captain Edward Smith, beginning her maiden voyage. It would stop at Cherbourg, France, and then Queenstown, Ireland, to pick up more passengers, and then begin its journey across the North Atlantic Ocean towards New York City. On April 14, 1912, warnings were coming in of icebergs from other liners, so Captain Smith had plotted a new course and continued to steam at full speed, which was standard practice. As it became dark, the temperatures were dropping to below freezing, and there was no moonlight or waves, making it difficult to see approaching icebergs. At 11:40 p.m. ship's time, the ship's lookout, Frederick Fleet, spotted an iceberg from the crow's nest. He rang the warning bell and telephoned the officers at the ship's bridge, shouting, "Iceberg right ahead." Fleet had spotted the iceberg with his eyes, as the crow's nest binoculars were locked away. The key's owner, Officer David Blair, had been removed from the Titanic's crew at the last minute and forgot to hand over the key. The officers on the bridge quickly turned the ship away from the iceberg, but it was too late. The Titanic grazed the iceberg along its side, ripping several holes in its hull below the waterline, with fragments of ice hitting the deck. At first, everyone felt relief. The lookouts and the passengers didn't even feel the collision. 11:50 p.m. Captain Smith and the ship architect, Thomas Andrews, went to inspect the damage. They knew the ship would start sinking, and by this time, 6 of the watertight compartments at the front of the ship's hull were already breached and began flooding. 12.
So your prediction was right. So why the Titanic sunk? Because of density. The Titanic collided with an iceberg and it caused large blank in the ship. Holes in the ship. Good job. These holes caused water to flood the compartments that were once filled with air. Good job. Due to the water filling the ship, it became
more dense.
Good job. More dense.
And began to sink.
Good job. So that's what the Titanic has to do with density. Thank you. That was all for today. I urge you to take what you've learned today about density and the Titanic and share it with your friends and family. Thank you.
Thank you, teacher.